Good morning. My name is Chris Small, and as Alex kindly introduced, this is Datalog all the way down. You can find me on Twitter and most other places as Metasaurus, so if you're interested in getting in touch with me, that's there. And my website's at metasaurus.com. Real quick, a couple things. I'm a co-founder of Polis. We're a startup that makes massive online conversations make sense with machine learning and data visualization. And we've been used in Taiwan and Korea to affect political change. And are currently talking with online newspapers about replacing the existing message board system. So if that sounds interesting to you, you can check that out at pol.is. Also, I do contracting and consulting work as ThoughtNode Software. So if you'd like to get in touch about anything along those lines, thoughtnode.com. So this talk is really about how we can leverage the superpowers of Datomic and Clojure to build more composable, data-driven web applications. And this story starts with one of the first web applications that I ever built. It was mostly a Rails CRUD app, right, saving, viewing data. But what was interesting about it was that it had a really complex domain model. And this led to a lot of object relational mapping and user interface challenges. But the other thing that was really interesting was that there was a sophisticated query system for traversing this data. And so, you know, there were some interesting problems. It was a fun project, and we built something really cool that solved some very real problems. And recently, I started talking with this company again about doing some extension on this work, and this really involved coming up with a much more complex data model that was capable of much more flexible relationships. But also, inevitably as a result of this, dealing with more challenging user interface and query problems. And I wasn't really interested in taking a big Rails project at the time. I'm pretty happy working with Clojure. So we started to think about what it would be like to write this in Clojure. What I didn't really expect was that Datomic would factor so heavily into a lot of the decisions we made. Datomic has Datalog as a query language, and that meant that we'd have a lot more expressive power in our queries, and that we'd be able to compose queries more effectively because queries are just data in Datomic. I also realized that the more flexible schema from Datomic meant that these really flexible dynamic relationships that this company had to deal with would be much more easily solved in this system. And finally, persistence would be a huge win for a company with concerns about data integrity and auditability. They care about their data and want to make sure that the data that's there in the database is the right data. So these were all really great things. But one of the clinchers was really, and perhaps the clincher, was really that with this system, we'd be able to build on top of Datomic's extensible schema. And what that meant is that we'd be able to build user interface which helped them manage what data they track and manage the relationships between that data. And that this would lead to an ultimately much more leverageable system for them. So I would never advise a rewrite lightly, but in this case, there were so many tangible benefits in the scope of work. Building on top of what already existed was so great that I realized we'd have a vastly simpler and more powerful system if we did this rewrite. So we did it. And at this point, of course, we had to decide what the architecture was actually going to look like. I mean, knowing that you have Datomic and Clojure in the picture is really just a pretty minimal basis. So one of the front-end architectural patterns which came to light recently for me and which really kind of resonated with me is the reframe architecture. And so reframe is a micro framework built around Reagent, which itself is a React.js wrapper. And it has this, it's just a set of patterns for dealing with state in Reagent. Reagent is very flexible about how you use state, and reframe just sort of kind of guides you into a particular way of doing things. And that particular way of doing things is to start with a central message log as your central database for your front end, which is nice for a lot of reasons. It makes things like certain testing situations, generative testing, a lot easier. You have the ability to go back in time and look at what happened, auditability, debugging. There are a lot of really nice things that come out of this. But one of the things that's unfortunate about it is that actually basing all of your UI decisions on this giant log of events isn't very efficient. If you want to do something, for instance, to show the number of connected users to a system, computing that every time from the log is going to be a huge mess. And the solution to this problem is to use Reagent's reaction or reactions to compose this sort of materialized view graph, this signal graph. There are different frameworks kind of call this different things, but the basic idea is that, we have some computation which is always up to date based on the central app database and any other further reactions which it might depend on. And so this starts to look like the concept of materialized views from the database world, and in particular, the architecture of Apache Samza, which heavily inspired Reframe. And so there were a number of things that I really liked about this. One is that there was some conceptual convergence with Elm and Redux, two very kind of popular directions right now. Hopalon as well. You know, there's a bunch. I think Javelin maybe that's a part of Hopalon, but there are a lot of things that are moving in this direction, and I think that's a sign that there's a real pattern here that has some value. But I think what I liked even more was that it was really thinking about the user interface as part of a distributed system. These systems have eventual consistency, which is a really nice property for dealing with a lot of the things that we care about. And I couldn't have asked for a better talk to follow. Michaela's talk was really wonderful. I think she's right. Like this is web development is distributed systems development, and so making sure that you're actually thinking about that is important. So it wasn't long before getting into Reframe that I found out about DataScript, and I think I'd heard about it at some point, but just sort of assumed that it wasn't going to be as impressive as it was. Honestly, it is an extremely impressive Datomic-like in-memory database solution for both Clojurescript and Clojure. And we have Datalog queries, we have pull expressions, we have transaction reports and listeners. We have a really amazing amount of coverage over the Datomic API. There's some things that it lacks, like durability and history, that you kind of that aren't too surprising to be missing on the client, and some things like idents that haven't been done yet, and other subtle differences. But all in all, it's a really amazing system. And what I really liked about this idea was when we're talking about Ohm or Reagent or any of these development frameworks, we're often talking about some central atom as our app database, right? Well, why not make it an actual database so that you actually have relations and you have all the things that we'd like from more expressive databases. So this seemed really compelling to me. But there is a problem, which is how do you connect the DataScript database to your user interface? Reagent kind of only knows how to work with its own version of atoms and reactions. And fortunately, I found a solution to this problem. There's a library called Posh, which does this kind of connection work for you, but it goes much further than that. It actually sort of takes inspiration from the Reframe library in coming up with this architecture reimagined as reactive DataScript queries. And this is a simple example of what this might look like. The first function we have here is called todos, and it returns a reaction, which we define using the Posh queue function. So Posh queue function takes our database connection, and it takes a Datalog query, and it returns this reaction, which is just this, again, it's this always up-to-date computation based on our database state. So below in this reagent components are just functions which return hiccup, data sort of version of HTML. In here, we call this todos function, get this reaction, and we dereference it, just like we would some atom of app state. And Reagent hooks things up so that anytime this reaction updates, this component will also update. So then, we can take each one of these to-do items that we get from this reaction and render it. And I'll just mention really quickly, we don't just have queue here. We also have pull, and we're working on a number of other functions that do things here. I should say Matt Parker has been doing this. I've been thinking with him a lot on it, but. Again, one idea leads to another. It wasn't long before getting into DataScript and Posh that I came across the Web After Tomorrow, which is this wonderful blog post by Nikita Prokopov, who's the author of DataScript. And I think the fundamental point that he makes quite well is that the REST API is an anachronism. It's a relic of a bygone era. And things would be much nicer with seamless sync if we had front ends which just had some subset of your central app database, and could efficiently subscribe to changes on that database based on security and scoping filters. Scoping filters being some restriction of what data do I actually need to render the page, so you don't have the whole database on the client, then you'd be able to kind of forget about the server, right? Which is kind of the direction things are moving. I think that the client is where all of this kind of dynamic stuff is happening, so the more you can move logic there, the better, I think. And he also makes a really strong point that Datomic and DataScript are perfect for this, right? They're log-based, so they have a lot of these really nice properties for being able to build a system like this. And I think this is really compelling. This isn't the only sort of instance of folks talking about moving away from the traditional REST architectures that we all know and maybe love or hate. But I think the fundamental problem here is that REST APIs are a terrible way to approach distributed systems. They hide a lot of complexity. And there's a really great post by Chaz Emmerich called Distributed Systems and the End of the API, which I think really clearly elucidates this. So you can find that on quilt.org if you're interested. But it's not alone there. There have been a lot of ideas that have moved things in this direction. Meteor.js is doing very like web after tomorrow style subscriptions on Mongo collections. OhmNext, Falcor, GraphQL, Relay, et cetera, are letting components directly query for data and are able to do this in a way where you have some static description of all the data you need and you get it all in one fell swoop. So you're not dealing with issues of multiple round trips and consistency as a result of that. Consistency problems as a result of that. But another really interesting direction are convergent replicative data types. These are data types which are sort of guaranteed by this merge operation to converge and to be consistent when you take two systems and say, hey, here's my view of the world, here's mine, and you merge them and you get something that's consistent. And so this is something that solves a lot of problems in distributed systems. As soon as you don't have to worry about these consistency problems with the data that you merge, it makes a lot of things simpler. So this really felt like the right direction to move. Distributed systems are hard, so the idea is isolate the hard part. And this is really similar to emerging patterns of state isolation, I think, in functional programming, and quite related, right? Like they're really kind of mirror reflections of each other. But a lot of problems come up here. There are a lot of things that haven't been sort of worked out yet. With the web after tomorrow, how do you describe these scoping filters? And how do you describe them or process them efficiently so that you're not, for instance, running a query for every single user for every single transaction that hits the database? And this isn't really a trivial problem. With CRDTs, there's the problem of garbage collection, and I think there's been a lot of active work here, but my impression is that there's still kind of some unsolved problems that we still kind of have to wait to see how things settle out there. But there are even mashup ideas. What if we were doing the web after tomorrow via CRDT log distribution? That could be a really powerful way forward that would have some really nice advantages for being able to take any two given clients and have them merge data, share data with each other without having to go through a central server. So peer-to-peer. But taking a step back, this is a lot of fun thinking, but for my client's case, fortunately, we had a small enough set of data that it could fit in memory, and the deployment was on a local area network, which meant that we didn't have to worry as much about security and authorization, authentication. All clients have full permissions, and there's no need for optimistic updates or offline availability. So I really only needed to solve a subset of this problem, and I thought, why don't I do this and provide a basis for something that we can grow into a more general solution? So the picture as it stands right now is we have a Datomic database, which is our central system state, and we stream transaction changes to all the clients. And in this case, we're just streaming all transaction changes because that's fine for our particular use case here. But this is, of course, where you could introduce mechanisms to make sure that you weren't sending data out that there was an authorization for, et cetera. Each one of our clients then takes those transactions and transacts them into its local DataScript database. So in the sense then, each local DataScript database becomes a materialized view of our Datomic database. From there, we can compose these reactive signal graphs based on our DataScript database and that's kind of the data flow right there. The only thing we need to complete the picture is we need for clients to be able to send transactions to Datomic. So we open up that ability, and all you have to do there really is once you send that transaction through, the transaction reports will come out of the flow that we've already described here. So this looked like a really approachable architecture. And had a lot of benefits. We'd have a really light server where we'd have almost no logic on the server. We'd hook up this sync stuff and then kind of forget about it, unless we needed to do some kind of heavy computation on the server to reduce strain on the clients. Strong consistency is good when it's not a drag. It's thinking about how we would do offline editing and all that sort of stuff is great, but we don't really need it in this case, and so you don't have to worry about that. Client components can be based on these expressive Datalog and pull queries, which is really awesome. Again, we're just syncing the databases, so we have the full expressiveness of DataScript to describe the data that goes into our user interface. And finally, I was able to do at least enough thinking to feel like there was a direction forward here to grow this into something more general that would solve or more robust set of problems. So all of this started to look really good, and so I started to work. One of the first things that I set up was the data sync, because that was obviously pretty important for everything else to work. And really here, most of the work was just in creating translations between the transactions. So you want to make sure that you can translate entity IDs between the two systems and such. And the rest of it was really just hooking up the data flow. So I've put together a library called DatSync, which has some utility functions for doing this kind of work, for syncing Datomic and DataScript databases. The only thing that's supported out of the box right now is this kind of full database replication. All clients get all transactions. But we're gonna work on solutions towards the more general problem. And this is on GitHub at Metasaurus DatSync. So again, most of the work is in the transaction translation, particularly with the entity IDs, and remote versus local versus temp IDs, et cetera. And the next thing that we do that's kind of useful is we can automatically update DataScript schema when Datomic schema changes come in. And this is actually updating the DataScript schema. DataScript, by default, once you create the database, the schema is fixed. So you actually have to drop the database and create a new one with the new schema. So this takes care of that problem. You know that you just don't have to think about the schema on DataScript anymore. You define it in Datomic, it goes over to DataScript. We flatten nested map structures for you when you try to transact them, and this means that you can do a pull request on Datomic and send that over as a transaction, and it'll work. And hopefully, again, this will be the basis for more general work in the future. So here's a quick example of how this would be set up with Sente, WebSocket server framework. On the client, you would have an incoming message handler, which would dispatch on some key, say, DatSync transaction data. And all it would do is just take that data and apply our DatSync apply remote transaction function. On the server, we do almost the same thing. We wait for this message with the same key and use the server's version of the same function. And optionally, well, right now it's also necessary to hook up some kind of a bootstrap function so that when things load, it gets the initial database state. But hopefully we won't need to do that once some of these other things kind of get smoothed out. The next bit of work to do is to hook up our transaction reports. So to do this, we use Datomic's txReportQueue function, which returns a Java blocking queue, and we pass that to start transaction listener, which is a DatSync utility function that takes as its second argument some handler for what you want to do with that transaction data. So in this case, the first function which we defined, handle transaction report, just sends all this data to all clients, broadcasts it. So if you wanted to do something more interesting, only send data to certain clients, et cetera, this is where that would hook in. And of course, we want to build things to make that a little bit more automated, but that's what there is right now. So that's it. That's the server. Again, unless you need to do heavy work there, that's kind of all there is to it. So now towards building flexible views. Again, this goal of the system was to be able to take in really kind of flexible data and have things be really dynamic, and users could add their own entity types and such, so they can track change how the data works in their system. And I realized that this meant, we couldn't be hard coding in views for specific kinds of entities. We had to have something very general that would just take data and render user interface. And maybe it wouldn't be perfect all the time, but at least that they'd have this ability to add some data type to their system and have it work. So I pretty quickly realized that the Datomic schema was a perfect starting place for describing the data that we need to do this. We already have a bunch of data here that's really useful. We know the value types of our attributes. We know the cardinality. We know the doc string. A doc string, for instance, could be used as a tooltip. But we can add our own attributes as well. We could add something like attribute label to an attribute, have a meta attribute, if you will, which would say that anytime we want to render a value, which is an entity name, we want to put the label name. Pretty straightforward. And I mean, this is maybe something you could automate to based on the ident keyword, but at least you'd have this ability to override it pretty simply. And so this leads us to this idea of defining our own semantic extensions to the Datomic schema, which I think is a really cool and powerful pattern. But one of the things that we need here is the vocabulary around entity types. So again, if users are going to be adding their own kind of types to the system and all this stuff has to work kind of in an automated fashion, you need some description of what the types are in the system. And Datomic is inherently polymorphic. It doesn't care what attributes you put together. It has no notion of types or tables or anything like that. So we need to build something in that does this for us. And I think it's really cool that you can so simply. All that we do is define some entities with an ident, and that ident is kind of what we think of as the type. So in this case, we have a to-do type. And we can specify that this to-do type is associated with the attribute's entity name. So pretty simple. This would mean that if we wanted to render a view for a to-do item automatically, we would know that we needed to give it a name field. And then to assign a type to some entity, we use this entity type attribute, and that's it. Now this thing is a to-do item. For references, there's a little more work to do. We need to say what kinds of references something can point to. There might be cases where you really don't care, and that's fine. But typically, you're going to want to, for instance, populate a dropdown with some set of items. And for that, you're going to need to know what kinds of items do I need to populate. So here, just having an attribute ref types attribute, which points to the types that you can assign for this attribute is the solution here. And there's nothing statically enforcing this, of course. This is just sort of a convention. And you could obviously work around it, which I think is kind of cool. It's really flexible. But yeah, it's all the guidance that's needed to make these things sort of automated. Now, putting things together into view functions. I'm kind of whitewashing or sweeping over all of the work in making these really general functions, because there'll be a lot to explain there. But basically, what you can note here are the pull view and edit entity view functions used in the to-do app component below. These are these very generalized functions which just take in data and based on whatever data you've put in the schema will render view for you. So edit entity view would specifically give you an edit form based on some sort of, in this case, we're just providing sort of a prototype of what we want the entity to be. We want to say that it's a to-do item, and then based on that, it's going to be able to, render all the fields that are necessary for entities of that type. Below that, we use the pull view component, which just takes some pull data, which you might get from a Datalog query like the one above, and it will just render whatever data you pass it to it. Again, based on the schema metadata and any sort of customization that's defined there. But just to kind of see where this can head, we can abstract things a little bit. We can make them a little more general. Here's an example of a type controller. We pass in a connection and some type ident, and we just sort of build everything dynamically like we did before, but where we just pass in whatever variable type ident is. And so now our to-do MVC app becomes type controller con entity type to-do. That's it. So you can imagine now how you could build your application if you had a bunch of different kinds of entities that you wanted managers for, you would just call this little function for them and route that to which type you were on. This looks really, this is just, when you think about the scaffolding that's involved in Rails and like the massive amounts of code that produces that you have to maintain, have fun with that. We don't have to do this here, right? These are functions. We can just use these, drop them when we realize that we don't need them anymore. So it's simple. Unfortunately, though, there are some problems. Nothing would be complete without some problems to solve. And in this case, I think the biggest problem has been performance. This is kind of wildly non-performant the way I wrote it. And I kind of wrote it this way on purpose to really push the limits of like what can you do with Posh in this architecture. And unfortunately, yeah, you have to be a little bit careful. That is sort of a reality here. If you have tons of queries going on, there's potential for getting into problems. But really here, a lot of the problem that we had was really specifically with this dynamic view stuff. I think for kind of simpler things going on that you were just doing yourself, you probably wouldn't be using as many queries. The problem here is that we had all this very kind of granular nested stuff because we had to make it all very general, and there's lots of kind of layers of queries for each component. And additionally, the actual domain data that we were rendering, we were sort of defining things such that it would query for one entity, and then it would separately query for all of its sub-entities. And of course, this is bad, right? This is, we're doing a lot more querying than we need to. And so the obvious solution here is don't do as many queries. Dat view is something, sorry, I haven't defined dat view yet. So this generalized view code is something that we can kind of do that work up front with. We can kind of, we can do the work of tuning that so that you only have to worry about tuning your own set of queries, which should make things a lot simpler. But Posh also has a number of things which are coming out now, which should be able to help us. So Posh has pattern matching kind of built in, and what that means is that as you, when you define your queries, it's able to statically look at them, both pull and some Datalog queries. It's able to look at them and often figure out, okay, this transaction doesn't have anything which has a chance of updating this query, so I'm not even going to rerun that query. That means a lot less work in getting things set up. Additionally, Posh, by virtue of producing these reactions, which behave like materialized views, they're kind of like little caches, right? So once you've created a reaction and you've done that computational work, as long as it's not updating, you have something that's not changing all the time, it's pretty efficient once that's set up. It's mostly on kind of this initial load that we have this problem. So one thing that would be really useful is for things that are going to kind of swap in and out frequently, but there's not enough of it to really worry about dropping it all the time, you can just specify something in Posh that would keep those reactions alive. And sorry, I should mention something specific. So Posh actually caches reactions even between components. So if you have multiple components using the same query, they're not going to get rerun. It'll only ever run once. So. But again, if there's something that we only wanted to run once we started the application and then keep alive, we could do that. And then it's just effectively a hash map lookup away. But we can also take a play from the reframe book, which is we can chain reactions together to kind of gate the computations that we're doing. And so some things that we're working on are Posh filter, which is sort of a version of DataScript's and Datomic's filter. And that restricts the database so that your scans are shorter. So this is potentially a big win for this flexible schema stuff, because really all we need there is the schema data. And so if we do a filter so that we're just querying on the schema data, we're now looking at a lot less data, and that should make things a lot better there as well. So how did this turn out? Amazing. It was every bit as awesome as I'd hoped. I mean, it's like what you saw. Like you say, render stuff for this entity type, and it does it, and that's pretty cool. There's some stuff it doesn't solve yet. There are definitely some problems, but it was really nice. It did the thing. The domain-specific query system, this kind of feels like a side note to a lot of the other stuff that's going on, but it's worth mentioning. It really worked wonderfully. Comparing the solution that we were able to come up with Datomic to what we had to do in Ruby on Rails with SQL databases, just a world of difference. So much easier to take some input data from the UI and sort of translate that into this Datalog query, which again, is just data. You're not composing SQL, it's just data. So looking to the future, Security, I think, is one of the next big things to figure out. And here I think there's something that, I'd really like to hear people's opinions on this, but I think REST APIs have become entangled with security and authorization concerns. And I think this is actually bad, because there's a lot of complexity to REST APIs. And I think that coupling these things has the potential for leaving little wiggle room for things to happen that you weren't aware of. In the architecture which we're talking about here, though, everything is just streams of transaction data. And I think that uniformity could lead to some really nice patterns in authorization and security. And I'm not a security expert, so take that all with a grain of salt. But yeah, I think it is compelling. And there may be some work to do to really get that right and to figure out what the right patterns are. But I think that there is a way forward. And I think the rough basis for this, how this might work, is from server to client, we need to be able to send transactions that hit the server. And I think the idea here is, people have talked about, well, one of the nice things about Datomic is we can create this filter database and filter out things that someone doesn't have authorization for. But we could also do this reactively, so that, again, we have this thing that's sort of like cached for us and updates whenever it needs to. And this reactive filter then could be the basis for filtering by entity ID and attribute for any given user what transaction data they actually are allowed to see. And so only those transaction datums would get passed on. But they'd have to get passed on to then some scoping filters. And the scoping filters, again, are what we would use to describe what data any given client actually needs to see. From client to server, we have to be pretty careful, because here's where we're actually writing to the Datomic database. So we want to make sure that anything that does get written is OK. And I think for this, we can do something based on pattern matching of our transaction forms with whitelisting and custom per operation filters, so that if you add your own transaction functions to the system, they're not going to be permissible from clients unless you explicitly say, this is how you translate this, and this is OK, this is whitelisted. For more expressiveness, though, we can also use database snapshots on peers, together with the Datomic with function, which gives us sort of this imaginary world, which is, what would the database look like if I transacted this data? Don't transact it, just tell me what it would look like if. And so that gives you both the database before and after, and also the set of datums produced by the transaction. So that's a lot of information off of which you can do some querying and figure out whether or not these datums are allowed by this user. And typically, this isn't something that would need to be run in a transaction function, but and you probably wouldn't want to, because that puts extra strain on the transactor. But as long as you're basing things off of a consistent snapshot, which is what Datomic helps give us, you know that if something was authorized recently, it's probably OK to still allow it now. So that's a thing. Scoping subscriptions. Posh, again, has this awesome pattern matching ability. So what if we use this for scoping on the servers? And I think this is really cool, because now we can start to see a convergence between some of the ideas from OhmNext and this architecture of data flow that we get from Reframe, right? So we describe these queries that we just statically send over to the server. The server does some analysis on them, does this pattern matching stuff, and builds these reactions which do the scoping work for us. So this work that I've been putting into this really flexible schema, I'm calling DatView just as a pattern right now. I hope to eventually make this a library. And I have high aspirations. It might end up being something that's just if you need some ugly user interface to look at your Datomic data and don't really care what it looks like, then it's fine. But I'm really hoping that we can make it into something more general. Right now, there's a lot of refactoring going on to make things more performant, but the stuff's there. I mean, it has been written and it works, so it's really just a matter of retooling it and organizing it a little bit better. There are a lot of challenges here. We want this to, at the bare minimum, be a set of useful helper functions for describing more custom components. But ideally, what we'd have is the ability, via pattern matching dispatch, to specify how we want certain shape of data to render. So by default, everything would render just kind of by these defaults that we set in the system. But for any given thing that maybe had a certain type or a certain property between things, we'd be able to customize the rendering. And hopefully we can do that in a way that's really sane and makes sense. But I think it would be also ideal if we could separate out style and layout specifications as orthogonal concerns that we can kind of mix and match and share and compose, et cetera. There are lots of other problems to solve. Offline data sync availability, of course. I think we could do I18N as schema metadata or as Datomic data. Efficient validations is kind of a problem. If you're running every single transaction in transaction functions that assert some validations, that again puts more strain on your transactors. So coming up with some good patterns there, I think, is an interesting question. DatView query composition tools. So I think one of the great things about OhmNext is that it really just focuses on pull expressions. We have pull expressions in Posh, and we have Datalog. But the nice thing about pull is that it's really easily composable, right? I mean, if you saw like some of the talk from yesterday, or you're doing anything with OhmNext, you can see like you just say, well, this is what the subcomponent needs, so let's just put that in here in the pull expression, and that's really easy and simple. I think we can copy some of that. Sorting, some utilities for doing things like sorting and pagination. But I think something that's really interesting and that I was just talking to some of the Onyx guys about is this idea of compiling to these reactive graphs that we would create to Onyx workflows of Datalog and pull queries. And I think this is a potentially really powerful pattern. So this means that we can build something on a small system and then just really quickly scale it out to an Onyx topology. There's a lot of work to do here, obviously, but it really feels like there's a coherent direction and some really cool patterns which are emerging. And I hope that you all can kind of take what seems interesting from it. But if you're interested in kind of looking more into all this stuff, I've put up Catalysis, which is just sort of an application template with some of these patterns. And so specifically, if you want to see what DatView is currently and what it's kind of morphing into, you can do that. But also, if you want to see an example of how DatSync hooks up, in a system, you can take a look at that there as well. This may eventually evolve into a micro framework, but again, for right now, it's just sort of an example application. The vision, though, just take a step back and think about everything we've discussed here. We want to be able to programmatically build web applications around schema metadata, DataScript queries and transactions, and declarative data sync. And there's a really nice convergence of ideas here, which I think makes this very compelling. OhmNext, Relay, Falcor, Reframe. What's the other one? Thank you, GraphQL. Reframe, Samza, Elm, all this kind of streaming materialized view stuff. The web after tomorrow, Datomic, data-driven programming in general. There's just a lot of really great stuff that I think is converging here, and I really feel honored to be standing on top of the shoulders of giants with all of this great thinking and to be able to put some pieces together which I think are interesting, and I'm really excited to hear what folks think about this. So with that, thank you. There's a few people I want to thank here. Matt Parker, creative Posh, Aquatic RNA has been doing a lot of work helping put Catalysis together and learning web application development along the way. Christian Mandrup, who's here actually, and who's contributed a lot of the docs to this system, and Infinite Cloud for supporting some of the work and thoughts on security stuff. So that's it. Thank you. Do we have time for questions? Is there time for questions? Maybe like one? Anyone? Yeah, we're there.
I'm still a little unclear on how this is fundamentally different than like the traditional back client architecture where you have a installed client on your user's box and Posh directly to the database. I mean, yeah, the data is coming in, it's basically like a little cache, but it seems like you still have a lot of the concerns that you have with the back client, making sure the client push out an update, how you make sure it gets down to compliance, and then you're also introducing a lot of security concerns, which you didn't talk about.
Yeah. So the question was, how is this different from kind of the fat client of old. And I think, so in the specific application that I built, certainly we could have done that. But yeah, I think the difference here is that we're really thinking about this from this distributed systems perspective. I think that a lot of the fat client architecture of old wasn't really doing that. And yeah, I think we have a lot of new patterns here that we can use to tackle some of these challenges with those architectures that we saw. One more? No? Yeah. Yes.
And don't you run into the danger there of, since UI views change very frequently, and they can reuse the same data across multiple views, but presented in different ways, of corrupting your data integrity, introducing, small aggregations and duplicate data and things of that nature within the database layer, and those really should be manipulated from the top.
Yeah, so I think, so let me try to recap that. Are you concerned, the question is, are you concerned about corrupting the central view of the world, the central database in this system? And I think here the key to this is that because we have this kind of reactive flow topology, at any point, the only thing that's actually going to update the central system is a transaction that you send out. So, so there's a distinction from anything that you might compute just locally on the client to say, have some materialized view that represents some efficient computation which you need for the user interface. You separate that out from anything which would actually be saved onto the client. And so there is a problem here, though, which I think you do touch on, which is that we are just saying here clients can just send whatever transactions they want. And that is definitely a security problem, right? We need to be able to think about how we ensure that that is safe. But again, I think that thinking about it from that perspective may actually lead to some really nice patterns because we can actually just say it's just a stream of transaction data and reason about that. Yeah. Yeah, okay, thank you.